Alright, I want to talk a little bit more about the most common two types of networks, which are local area network and wide area network. So do you remember from the last video what LAN and WAN are? LAN, we said, is local area network. This is typically found in your homes, offices, schools, libraries, or generally in smaller places. It is designed for connecting devices like computers, printers, and servers in a close proximity environment. So let's, for example, take home network in this case. Your home network is a local area network or LAN. It consists of several devices, including your laptops, computers, printers, mobile phones, and a router. Now, router is a device which we'll talk about in more details in the next lecture. But for this case, just remember that router is an important device inside a network. All these devices are in close proximity of one another, which is why it is called local area network. Now keep in mind, there is also something called VLAN, which we mentioned in the last lecture, and that stands for wireless local area network, and it is the same thing just for wireless devices. These devices inside of local area network are then given something called private or local IP addresses. IP addresses are also something that we will talk about later, but for now, remember that these local IP addresses are something that these devices use to communicate inside the local area network. Another thing about LANs is that they are typically owned, operated, and controlled by a single organization or entity. This allows for a high level of customization and security. LANs also typically offer higher data transfer speeds and bandwidth compared to wide area network. This is because LANs are designed for local and internal use, allowing for faster communication between devices. Also, local area networks are generally more cost-effective to set up and maintain since they cover smaller areas and involve fewer networking resources. Now, WANs, on the other hand, is a wide area network. In its simplest form, a wide area network is a collection of local area networks or other networks that communicate with one another. A wide area network is essentially a network of networks, with the internet being the world's largest WAN. Examples of WANs include the internet, a global corporate network connecting offices worldwide, or a telecommunication network spanning a country. Wide area networks can also be used in a military. Now, some of the advantages of wide area networks are that you can share information and files over a larger area. WAN helps you to cover a larger geographical area. So, for example, business offices situated at a longer distances can easily communicate, thanks to wide area network. But some of the disadvantages of WAN is that the initial setup cost of it is quite high. It is difficult to maintain the WAN network as you need skilled technicians and network administrators. It also requires more time to resolve issues because of the involvement of multiple wired and wireless technologies. So these would be some of the basic stuff to remember. So let's recap real quick. In summary, LANs and WANs serve different purposes based on their geographic coverage and scale. LANs are localized networks used for internal communication within a limited area, while wide area networks connect LANs across larger geographic regions, enabling global communication. Each has its own advantages, and they're often used in conjunction to create a comprehensive network infrastructure. Okay, let us make a quick pause. I just want to recap what are the goals for this course. The goals would be to actually understand how a small network works. And if you can see in front of you, we have an image where everything is exchanged with question marks. This image is actually a small network, and these question marks exchange various different information such as devices, protocols, and other ways of communication inside the network. All of this is something that we are yet to cover, so as the lectures go by and as we gain more knowledge, we will be updating this image, and hopefully by the end of the course, you will fully understand how a simple network functions. Alright, let's not make this any longer, and let's move on to the next lecture where we're going to shift our focus on MAC addresses. Okay, we talked about LAN and other types of networks in previous 2 videos. But before we dive into different network devices and their purpose, we must first mention how are these devices identified on these networks. There are 2 main things that identify a device inside the network. We have MAC addresses and IP addresses. Now the main difference between these 2 is that MAC addresses are unique, while IP addresses are not always unique for every device. Now, since we will talk about IP addresses later in the course, let us now shift our focus just on talking about MAC addresses. So, what are MAC addresses? A MAC, or Media Access Control Address, also known as hardware address or physical address, is a unique identifier assigned to a network interface controller or network adapter in a computer or networking device. Now, MAC addresses are used at the data link layer or layer 2 of the OSI model to identify devices within a local network such as an Ethernet or Wi-Fi network. Some of the key characteristics of MAC address is, as we mentioned, uniqueness. Each MAC address in the world should be globally unique. This uniqueness is ensured by Institute of Electrical and Electronics Engineers, which allocates specific blocks of MAC addresses to different manufacturers. Another characteristic of MAC address is that it is non-changing. While it is possible to change or spoof a MAC address, it is typically permanent, factory-assigned identifier. MAC addresses are designed to remain constant for the life of the network interface. They are also fixed format, and this means that MAC addresses are typically represented as a series of 6 pairs of hexadecimal digits separated by colons or hyphens. The first 3 pairs often indicate the manufacturer's identifier, while the last 3 pairs are the device's unique identifier. Now, to understand this, here is an example of how a MAC address looks like. The first 6 digits of the MAC address, as we mentioned, identify the manufacturer, while the rightmost 6 digits represent the unique identifier assigned by the manufacturer to the specific network interface card or device. This identifier is unique among the devices produced by that manufacturer and is often referred to as the device ID. Alright, these would be the basic things that you should know about MAC addresses. Later in the course, we will see commands that allow us to find out our MAC address on our device, but for now, let us move on to the next lecture where we will talk about important network device or network components. Okay, enough about types of networks. Let's finally dive deeper and figure out what this network even consisted of and how does it actually work. How is data being transferred between the networks, and how does each network know which device to forward which data to? Well, these are the questions that we want an answer to, and answer lies in the way that network is structured. There are several devices you may or may not have heard about, and these include routers, switches, and modems. These are crucial, for example, for your home network, for you to be able to access internet from your computer. Of course, it's the cables that are important, but what's the use of cables if we don't know who to forward the packets to? So how does it all work? Well, let's start by talking about routers. Now, a router acts as the traffic director of a network. They are responsible for directing data packets between different networks such as local area networks and wide area networks. This leads us to router's number one purpose, which is routing. Routers use routing tables and algorithms to determine the best path for data to travel from its source to its destination. They make decisions based on IP addresses, ensuring data reaches its intended target efficiently. It is also important to remember that routers work at layer 3 of the OSI model, which deals with IP addresses. Now, the OSI model is something that we will talk about later in the course, but for now, just remember that router functions on layer 3. Now, typically, routers today will perform the functionality of both a router and a switch. That means that the router will have multiple Ethernet ports that devices can plug into. Another use of routers is for network segmentation. Routers help segment networks, creating distinct broadcast domains. This segmentation enhances network security and reduces congestion. And also it is important to note that routers often perform NAT, or network address translation, allowing multiple devices within a LAN to share a single public IP address. This conserves IPv4 address space and adds a layer of security. Now, I do understand that some of the terms that we talked about might be confusing for you, such as, for example, IPv4 or public and private IP or NAT, but don't worry about it for now. This is something that we will talk about shortly. For now, just focus on the main usage of these network devices. So let's repeat. Router is responsible for directing data packets between different networks by using routing tables to determine the best path for data to travel from its source to its destination. But what about switches? We mentioned that in some cases, routers can perform both functionality of a router and a switch. But what is the functionality of a switch? Well, switches, they use the MAC address of a device to send data only to the port the destination device is plugged into. Switches work at layer 2 of the OSI model, which deals with MAC addresses. Switches maintain MAC address tables to understand which devices are connected to which ports. This enables them to make forwarding decisions efficiently. That cable going out of your PC into the switch port is written inside the MAC address table inside the switch, so it knows exactly where your computer is and on which port should it forward the data to for it to arrive to your PC. Now, some of the pros or usages of switches are switches form the majority of network devices in modern data networks and carry huge amounts of traffic in telecommunications provider networks. Switches provide the wired connections to desktop computers, wireless access points, printers, industrial machinery, and some Internet of Things devices. They offer full duplex communication, connect network segments, boost network performance, and make effective use of available bandwidth. Now, network switches can be easily confused with routers. However, they have different functions and operate on separate layers. These differences include things like, for example, a network switch is a layer 2 device on the OSI model, and a router is primarily a layer 3 device. A router moves data between 2 or more computer networks, while a switch facilitates the sharing of resources by connecting multiple devices on a single LAN. To determine the route and destination of a packet, a router examines the IP addresses of packets, and a switch looks at the MAC address of each device to transfer data to the correct destination. Routers can work within both wired and Wi-Fi networks, but a switch is in most cases restricted to wired network connections. Okay, so these are some of the main differences, but we have to mention one more device, which is modem. What is a modem? Essentially, a modem is the device that physically connects your network to your ISP's infrastructure. It establishes the initial internet connection by translating digital data from your network into a format that can be transmitted over the ISP's network. Modems are essential because they're designed to work with different types of physical connections and communication standards or protocols. Each type of modem is tailored to a specific type of infrastructure or medium, allowing it to transmit and receive data over that medium effectively. Here are some examples. DSL modems are designed for transmitting data over standard copper telephone lines, typically using the digital subscriber line technology. Cable modems are meant for transferring data over coaxial cable lines, commonly used for cable television services. And for example, fiber optic modems work with fiber optic lines, which transmit data using light signals. Now, same as with switches, modems can also sometimes be confused with routers. So to summarize the differences that you should remember, we can say that modems and routers are complementary devices in a network. Modems provide the link between your network and your ISP, enabling internet access, while routers manage local network traffic and provide additional features like Wi-Fi connectivity and security. In many home network setups, these functions are combined into a single device for convenience, known as a modem-router combo. Okay, client-server and peer-to-peer networks. What are the differences? Now, before I say what is what, let me first define what is client and what is server. Client is a device that is requesting a remote service or that is using a remote service from a server. And as you might have guessed, server is a device that is hosting that service to the client. A most simple example which all of you are familiar with are websites. Website is a server that is hosting a web page to you who wants to visit it. So your phone or laptop would be considered a client, while the website is considered a server. Now that we know this, it is rather simple to explain a client-server network. We can define it as the network that is organized around a central server that provides resources, services, or data. Clients, which can be individual computers or devices, request and use these resources. Servers are responsible for managing resources such as files, databases, web pages, or applications, and clients access and use these resources by requesting them from the server. It is often considered centralized since servers in client-server networks are typically more powerful and have more resources such as CPU, more memory, and larger storage compared to the client's devices. They handle requests and provide services to multiple clients simultaneously, and that is the reason why they also have to be more powerful. Now, on the other hand, peer-to-peer networks are opposite. Devices or peers in the network have equal status and can act as both client and server. Each device can request and provide resources to other devices in the network. It is also considered decentralized since peer-to-peer networks lack a central server. Instead, devices communicate directly with each other. They share resources such as files or processing power without relying on a central point of control. Each device in a peer-to-peer network is responsible for managing its own resources. Devices can share files, printers, or other resources without needing a dedicated server. It is normal to consider that in general peer-to-peer networks are less costly than client-server network. Alright, this would be the basic differences between these two, so make sure to remember them. Now that we got basics of networking out of the way, and that we discussed MAC addresses, types of networks, as well as network devices and their use, let us shift our focus on discussing different network topologies in the next lecture. See you there.